You're watching Post Perspectives Meet the Artist podcast, sponsored by Puget Systems.
Hi, I'm Randy Altman with Post Perspective. Welcome to the latest episode of our Meet the Artist podcast. For this edition, we had an interesting conversation with Niko Pueringer from Corridor Digital and Matt Bach from Puget Systems. We spoke about AI and the creative process in the making of the video anime Rock, Paper, Scissors. I hope you enjoyed as much as I did. Hello, guys.
Hey, how's it
Hi.
going?
So we're just really here to have a conversation about trends, AI, Corridor Digital's videos, which you guys have been putting out thanks to AI, and how you're able to work in AI, and that's where Puget comes in. So why don't you guys just quickly describe your companies, and then we could just jump into the conversation.
Sure. Matt, you kick things off.
Oh, sure. Okay. So I work for Puget Systems, or a workstation manufacturer, and we do a lot in like media and entertainment, content creation, video editing, motion graphics, and AI for us is, we're always looking towards the future. What are people going to be doing, in the next 1 year, 5 years, 10 years? It gets a little hairy after that, and so right now AI is just such a big explosion, and it's kind of Wild West. It's changing constantly. Like you might look up like a guide for something, and if it's 2 months out of date, well, it might not work anymore, or you have to go back and use old stuff, or there's way newer things. And so our kind of role in AI and just media and entertainment in general is to come in and just give people the tools so they can get their work done. I mean, a lot of this AI stuff especially, and if you want to do it in a reasonable amount of time, you need a lot of processing power for it. Unless you want to shell out a lot of money and do it on the cloud. But cloud stuff is expensive. And so a lot of people, especially if they're just dabbling in it, they want to be able to do it locally so they can throw spaghetti at the wall. They can try something, and all it costs them is a little bit of their electricity bill and time. It's not costing them thousands of dollars. So our role, specifically in AI, because it's kind of what we're focusing on here, is just to give people the tools to do what they need to do. And that's actually kind of our relationship with Corridor, is we help them have the tools that they need to do for the work that they're doing.
Yep, exactly. So, yeah, Corridor is I can say production company, a studio that's been around since 2009, 2008, 2009. We started doing YouTube as like a career path in like 2010, kind of 2011. And since then, a lot of our company has been formed around the YouTube side of the business. But, we've also produced some films, some series. We have our own website, our own streaming service, our own website that people can watch our content through, no ads. It's all, independent directly through us. Um, and a big aspect of what we make, it's all very technology driven, visual effects usually driven, cinema driven kind of content. So we do a lot of cool sci-fi stuff, action stuff, a lot of visual experiments, things like that. And for us to make what we want to make, because we're a small studio and we've always tried to kind of pursue some of these bigger kind of Hollywood style aesthetics with our films. A lot of what enables us to do that is just using the most cutting edge technology that we can. Whether it's high end 3D packages, rendering packages, cutting edge digital cameras, or machine learning and artificial intelligence for imaging and all that kind of stuff. But it's all still with the purpose of trying to let us bring something to life that doesn't really exist. To visualize cool things. It's just we don't have a team of hundreds of visual effects artists to do that.
So when you talk about trying new technology to accomplish what your goals are, one of the recent videos that you guys produced was anime Rock, Paper, Scissors, which is hysterical,
Yep.
very funny. But can you talk about how that came about and why you decided to use AI to produce it, and what aspects of it were AI?
Yeah, for sure. So the story kind of begins in August of last year, so close to a year ago, but not even a year ago, and with the kind of the release of various diffusion models and diffusion algorithms. And diffusion is a way of, I guess, doing imaging through a computer, through a machine learning method, where basically you've trained the computer to imagine a picture from noise. And you get there by training a machine learning algorithm to remove noise. And then at a certain point, when you feed it pure noise, it removes it and just imagines what the picture would have been underneath all that noise. Um, the ability to then guide this, so it's not just a random picture, but it's something with a direction and kind of a knowledge of visual patterns, and it can work towards that. When that was kind of combined with this method, it started unlocking a new way of creating imagery. Because effectively you're dealing with a almost like a very lossy kind of compression where it's like the computer remembers suggestions of the images. Like you can kind of describe it as, I can kind of fill in the gaps. It's like imagine a very smart compression algorithm where like, if you give it a blurry picture, like if you give a human artist like a kind of a blurry picture of a person, and like let's say they're a good portrait painter, they could just kind of imagine what the details are and they could paint you probably a crisp version of that blurry picture. And that's kind of how this machine learning algorithm works. So if you can kind of guide it and teach it to represent certain things visually, you can start interpreting. It basically becomes a very high powered video filter. You can start interpreting videos and pictures differently. So one of the first things that kind of like, this stuff had kind of come out. The first Mid Journey had come out. The first like diffusion model, stable diffusion had just come out, and it was cool. You could generate stuff. It's a little janky. There weren't a whole lot of tools for it, but it was open source. But then this I guess this method came out called Dream Booth, which is a way to train new data into these models, these just general models that could do a rough picture of a tree or person, or roughly mimic like an art style. It could do all these different things, but it wasn't like a directable, like give me this thing that you really want. It's kind of just a general, it's a machine learning model. It's a generalized computer model of everything that it can see. But when we realized that we could train in like pictures of somebody or pictures of an object, or even like a certain art style, and realized that we could direct this model to reproduce that, that's when it started opening up this kind of creative door for us. And one of the first things that happened was we had, so there's this Dream Booth method. These algorithms are made to run on like basically data center computers, like big servers, clusters, that kind of stuff. In this Dream Booth process to like put ourselves into the model, like pictures of ourselves, so we can be a knight or a gnome or an elf or whatever. We made just a dumb little fantasy story as a test. But this process took about like 36 gigabytes of VRAM to run. You had to hold the whole model in the system, and we happened to have this AI machine that Puget had built for us, actually for doing deepfake projects, like a year before, and that had a GPU that had 48 gigabytes of VRAM. We just happened to have it sit in our studio. Not, I was gonna say sitting around. It wasn't sitting around. We were using it, but like, it's just one of those things. Like, oh, this is very serendipitous, and because of that, we were one of the first ones to put out a fine-tuned, self-trained diffusion model used for storytelling, where we did our little fantasy story. And like, it wasn't a big deal story-wise, but it was more of this new progression in tech where suddenly it's a realization we have a new way of creating images, we have a new way of kind of realizing stories. And the next step, of course, for us was video. Images are cool. Let's make it move, right? The problem with the diffusion system is that it's noise. You put noise on an image and it interprets noise. Well, noise is a random thing, and if you're doing frame after frame after frame, it's random noise each time, and that creates a very crazy amount of flickering and reinterpretation on a frame by frame basis. So trying to solve or figure out the video pipeline for using this imaging process was very challenging. And that's basically what was kind of the end, like rock paper scissors. The first anime rock paper scissors was kind of the first end goal of that, where we had done a lot of experiments, tried a lot of different things, and not just in the machine learning space, but using just classic visual effects techniques. Like, one of the big breakthroughs for us was discovering that, well, there's a deflicker filter in DaVinci Resolve, and it's meant for like flickering LED lights or fluorescent bulbs or that kind of stuff. And we had used it in the past to fix exactly what it was intended for. And we were looking at the flicker that this AI process would create, and we're like, it's kind of like flickering LED lights. And so I just tried applying the filter, and then I like copy and pasted it, and so there's like a stack of like 6 of them, and it cleaned everything up, and it worked really well. And we kind of realized that if we fine tune our own model on our own character with our own like very specific art style, so it's not being interpreted a million different ways, and the character is not being interpreted a million different ways, and we then run this through a kind of a traditional pipeline of like image cleaning up, like getting denoise in there, getting deflicker in there, and all that kind of stuff. Dirt removal, like automatic dirt removal tools even works. They remove little pops of stuff. Applying all that, suddenly we had a decently cohesive image. It was still janky. It was super janky, but like you could actually see a consistent character in there underneath that flicker. It was like, a first time animator trying to animate something, and all the lines are jumping all over the place, but it was still kind of an animation. So we wrote this. We had this idea for, we do these like, basically take something mundane, and we make it hyper dramatic. And that's like our anime video series. We did it with baseball. I mean, some people don't think baseball is mundane, but we did it with baseball. We did it with a self-driving car race. We did it with fidget spinners, or it was like a fidget spinner competition. And we had this idea for a rock paper scissors competition, which is like, it's a kids game, right? It's flip a coin basically, but slightly more complicated. Um, and we had this idea of just this hyper dramatic rock paper scissors story, and we hadn't shot it for a while, like, yet, because we've done our other videos live action, and this one we had held off on doing it because we're like, we kind of, I don't just do another live action anime video. Like, it'd be cool to actually do it as an anime, because we're visual effects artists. We've done cool animations before. We've worked in the computer with all different layers, and you know it's a lot of work. We're not traditional, like, animators. We can't draw like those kind of characters. We don't have that kind of a pipeline. So we decided to combine this way of filtering video and imagery, and we decided to try to make it look like a cartoon. We tried to make it consistent, and we combined that with this idea for an anime rock paper scissors game, and anime rock paper scissors, as you know, it was born.
And I think it's worth pointing out that I think a lot of people have seen like Stable Diffusion or the new like generative fill in Photoshop now they have in the, I think it's still in beta. And I think a lot of people look at it and they see like what you've done or what other people have done and like, oh, well, all they did is provide text and then it like made it, or they gave it an image and they told it, turn it into another image and it just does it. I think one of the things that's worth really pointing out to people is that if you try that with just the base models that come with things, the trained computer model, if you try it, it's not going to turn out well because it doesn't know exactly what it is you want. Because it's been trained on. I mean, you're going to generalize here. If it's trained on every image on the internet, it's going to be really good at drawing like cats and dogs.
Yeah.
It's not going to be very good at drawing Niko or me because there's like 4 pictures of me on the internet that are just like out there. So like I can draw based on those 4, but it's not going to do a very good job. But then again, like dogs and cats, there's billions of pictures of those. So that's why the thing that's really important to do if you want to do this like for something as high quality as what you guys did is you have to take the time to do the training of the model, and that's what takes a lot of compute time. When you're talking about like the video memory on the GPUs, like you're using 48 gigs, that's not really for the generating of it, it's for the training of it.
Yeah.
And I know you guys even put out I think it's on your page of like a whole guide. You went through the whole process of what you did, and didn't you have to take like pictures of you in every pose and different angles and everything, right?
Yeah, I mean, because it's basically, I basically applied the deep fake like world of training over to like the diffusion process, where when you're training a deep fake, it's you provide it as you provide this model, like you said, the machine learning and AI space. It's confusing for a lot of people because you have code, you have computer code, and then you have the model, and like, well, what's the model? Is it code? It's like, well, so it's like you have an algorithm to basically train a computer. Like, you give it a bunch of data points and the computer's going to try to find a correlation or a pattern or something, right? It's just going to roll the dice a million times and tweak things a million times until it kind of it gets something worked out. And that's something that's just become possible because we live in the future where as CPUs and GPUs have just gotten more compact and they're more prevalent and they're all over the place. It's like, I guess I can process a billion things at the same time now. So you have the code that's just running the instructions, but then you have to actually do the processing and create that data, that knowledge, and that's the model. So when it comes to deepfakes, it's about showing the computer a picture of a person basically in every possible situation, under every possible lighting condition, every possible angle, every possible expression. Ideally, you cover everything, and the computer just has a perfect imprint of everything. And then from there, it can generalize, where it goes. And having done work with deepfakes, you can kind of see when the computer is like pulling from one angle versus another. It's like, let's say one angle is like outdoors, another angle is like indoors, and like you can kind of see it, like, oh, there's kind of like sunlight on the skin there. That's weird. And you can tell how it's just pulled this knowledge of these images, and it's kind of this is the metaphor everyone uses, and it's not 100% accurate, but basically collages them. But you have to imagine like a human kind of like generalization kind of collage, not like a cut things out with scissors and paper collage. Like a knowledge collage, aka a model. Yeah, and like taking that world of deepfakes and going over to diffusion models and be like, okay, here's a generalized model, which when you do a deepfakes, you start with a generalized model of faces where it's just been trained to generate any face randomly. NVIDIA actually has a data set of like 70,000 faces that you can download and you can use for training. And you start with that with a deepfake because you don't need to start with a specific data set when you're just trying to get it to not be a blob. Like it's like go from generic blob, practice until you can at least get like eye blobs, a nose blob, a mouth blob. Like that alone is a big step forwards for like a model, right? Because it's going from no knowledge, from noise into a pattern. But once you kind of are getting to the point where you can kind of start to see detail, that's where you stop with like random faces and you go over to a specific face because now you want to draw the eyes only a certain way. And so right now, what is that at the moment of this podcast or at the moment I was recording this, but will probably be outdated by the time this podcast comes out, is right now there's the Stable Diffusion 1.5 model, which is kind of this generalized, hyper generalized image model that's trained on 5 billion pictures and can do everything kind of roughly, right? That's the equivalent of our deepfake model trained on 70,000 random faces, where it knows there's eye blobs and nose blobs and mouth blobs, but in terms of doing a specific detail, it doesn't have that because it's been focused like that. So that's where, hey, let's take this deepfake idea of as many angles and expressions and poses as we can, and then do that instead into a diffusion model. And we ended up basically with this, and it's called fine tuning. A lot of people do this now. But you basically end up with this, hyper specific knowledge of a single character or a single thing. I mean, it could be anything, right? Any visual pattern that you can think of. It could be a color grade. It could be a film style. It could be anything. Which also kind of opens the door for like, hey, I can film something with my phone and be like, make it look like an Alexa, and like have that generalized look, which is, going to be crazy things for, the camera industry in a few years. But yeah, bring this like this specific focus to it. One of the cool things about the diffusion model is it has a lot more general knowledge. So you don't need to give it 5,000 pictures of a face. You can give it 100 pictures of a face or even like 20 pictures of a face, and it'll kind of just fill in the rest of the gaps with its generalized knowledge, which can be a problem when you're trying to be consistent in video because you don't want it to be filling the gap one way and then a frame later it's like, actually I'll draw it like this instead, and it's like, no, draw it the same way you just did. So yeah, the training aspect is like, that's really where the magic happens, and that's one of like the most foreign things about machine learning compared to like the other forms of coding and programming out there. But it's also perhaps the most artistically understandable and open because you don't like models aren't, it's not logical code. They're just these meshes, these neural networks of like random numbers, effectively of multipliers. So it's really just you put something in and you get something out and you just kind of see what happens, and you study that process. You put something new in, you tweak some sliders, and something comes out. It's like, okay, that's what the sliders do, and you really just kind of have to learn by feel. And that's a perfect way for I guess somebody who's not super technically savvy to be able to approach something, because you hit buttons and you experiment and you just learn, and it's kind of that same starting point for anyone, no matter how sophisticated you are when it comes to this stuff. So it's been exciting in that regard too.
You're watching Post Perspectives Meet the Artist podcast, sponsored by Puget Systems.
And Niko, you guys have a new video coming out. I guess the sequel, would you call it? The next chapter?
Yes.
So,
Anime Rock Paper Scissors 2. We've been working on it for about 4 months, maybe a little bit longer. We went hard. We were very ambitious, but we had a lot of things we wanted to try. So we have a sequel coming out.
when you did the first one, you said you had the workstation, you were using it, but it was laying around. Did you then reach out to Matt and company and say, "Hey, we're
Yes.
doing another one"? So talk a little bit about that process.
Yes.
What you needed, what you learned the first time, all of that.
Yes. So we already had really nice computers thanks to Puget. Like we were running 3090s, so machines have multiple 3090s in them. And most of our machines are built to be editing powerhouses. Resolve, Blackmagic DaVinci Resolve is our main editing program, which is, it's easy to focus on the really cool stuff, the AI stuff, which in like rock, paper, scissors, even the AI aspect was maybe like 10% of like the actual process for a shot, because you have to like write the piece, you have to storyboard and plan your shots, you have to build your costumes, you have to have your production day and film the whole thing, come up with your cinematography, you have to edit the thing. Then you get to train your model on the pictures of your character, which is cool. And then you run your video through the process, the diffusion process. So that's the cool AI part. And that's it for the AI part. Now it's back to, now you have to take your stuff, you have to composite it, you have to animate it, you have to add your effects to it, you have to put it back into the edit, you have to add your sound design, you have to add your music, you have to add your color grade. Like, so it's just a slice. It's just a small slice of the overall process, but it's the one, it's the 10% that we're all talking about right now these days. But yeah, sorry. So we had a lot of, obviously really solid machines here, mostly running 3090s. But that 4090 was a spicy GPU, and Ren got the first one. And he was doing a bunch of like renders, Octane renders, and the 4090 just crushing it. And he was out for like 2 days at a one wheel race. And so I'm like, I'm going to jump on his computer and see how fast it is for this AI stuff. And it's like twice as fast. I'm like, this is way faster. This is a big step up. So we reached out to Puget and we asked very nicely if they would help us upgrade our machines to 4090s, which they did. And the pace at which our stuff improved was significant because we were able to do experiments so much quicker. And because we were able to do experiments so much quicker, we quickly realized that the process we were doing for rock paper scissors 1 was not going to work for rock paper scissors 2. So we had to pivot to a new process, which would have, if we were running it on 3090s, would have been a lot slower because you have to learn a whole new way of doing this stuff. And yeah, we were just, I had every 4090 in the office running, just putting out shots and like practicing things, doing, like you take a shot and you have it set one way on a setting, you have it set another way on a setting, and you just tweak everything a little bit, and you render out 8 of them. And then you compare them and you're like, there's the perfect setting. Because once again, no one knows. Like, this is a brand new frontier, which is so exciting about it. Like there's no tutorials for this stuff. There's no one who's like established how to do it.
Well,
So even
and
like,
the models and everything, they're all kind of black boxes. Like no
yeah,
one knows
exactly.
how they work because
Right.
they are not like a straight up like code. It's not JavaScript or C++ or something where like you can go through it and follow it. It's just a whole bunch of random stuff because the computer trained itself. And so
Yep.
you don't really know what you're going to get. And so that's why I think more important than like the final, you throw everything in, hit go, and then it renders everything out for you, more important than that, like you're saying, is the iterations because you have to play around with it. It's not a
Mm-hmm.
one size fits all. Like in video, it's often like, oh, what's the best encoding settings for my video if I'm going to be uploading to YouTube? And like, yeah, there's some like rules of thumbs. There's no rules of thumbs. You have to be able to tweak and try things and do different things and kind of just see what you get. And that's what I think is the biggest thing with like higher performance, new stuff from NVIDIA, when there's going to be a 5090 or whatever that's going to be, that's why people are going to want to be investing in that technology is because it's the amount of time that they can save. I mean, everything comes down to time, like
Mm-hmm.
more than anything else.
Yeah, and like we're still very humble with our render times because I started doing visual effects and like, I mean, IMAX had just come out, right? The iMac one, like that's when I was starting to do visual effects. Like it was very slow. It took a long time to render stuff, and it's like ever since then, like even if something takes a minute to render, I'm like, that's great. I love it. Minute per frame. That's so fast. I'm just so used to that. But in reality, especially with this like machine learning stuff, you imagine like, what if you can just move the slider? What if you can just scrub through the timeline and you just see it happening? Like the speed at which you can then just create and flow would be super cool. And we're not there yet, but honestly, like right now, the cutting edge GPUs are pretty close. And on the code side, on people making these things, this stuff's brand new. Like it hasn't even been out for a year, but people are rapidly making it more and more efficient. And so these kind of two things are coming together, along with like driver support and like these different like libraries that are used to run everything. Like all this stuff's getting upgraded and like more efficient, and like it's already going fast. You said this at the beginning of the podcast, but all this stuff is developing fast. And it's nice to have a fast GPU to keep up with it.
Yeah. So Matt, what did you learn from the process in terms of working with Niko and those guys? And what would you recommend to those folks out there that are looking to not? I'm not saying so. We do have to talk a little bit about the AI thing and how people are unsure and a little scared and stuff like that. But what would you recommend to people that are looking to dip their toe in the world of AI and machine learning in terms of
Yeah,
workstations?
well, sure, sure. Well, I think the first thing is really that you can really get started with very low end stuff. Like you don't need a 4090 to start playing around. It will limit you in like what you can do. Like if you want to generate, big images, well, you might not be able to cut it down, whatever. You're just learning right now anyway. You don't need to be generating HD images. Turn it down to 512 by 512. I mean, a lot of stuff is actually even intended to be done at this smaller thing. So you're really supposed to be doing like a part and then pasting it into like a bigger video. So I would say, I mean, number one is don't really let your hardware hold you back from starting. Just start, and then once you have like, oh, okay, I need more video memory because I want to do X, then start looking at doing upgrades. And what do you need? I mean, also too is if AI is what you're really interested in, this like image or text to image stuff or image to image, the stable diffusion, I mean, that's not the only AI things that are out there. I think, if you're like a video editor, there is a lot of stuff you're probably doing right now that you don't even realize is AI, but it actually is AI behind the hood. I mean, I think a lot of people are aware of like content aware fill in Photoshop and After Effects. Yeah, that's AI based. I mentioned the generative fill in Photoshop now. Like that's AI based, and that is a blast to play around with. And that one too is interesting because it's actually done on Adobe's their cloud service. So it's not actually being done on your local system. So you can be doing that on a little cruddy laptop from 10 years ago, and as long as you have internet, you can actually do it and you can play around. But yeah, there's so much going on. I mean, Nico, you mentioned how you guys are using Resolve now for most of your stuff. The current Resolve beta
amazing
is
tools in Resolve.
nuts.
Yeah.
Yeah. And I don't know if you checked out the beta, but the beta has like auto masking based on like depth. So even without depth information, like it'll know that this is behind me and it'll mask me out. It can do person masking. So you like just say like, oh yeah, track the person, and it'll just automatically do it. And it's not perfect, but it can get you 90% of the way there. They have like, you can relight a shot. You can do like slow motion. So if you shoot something, at 24 FPS, normally if you do slow motion on that, it's, chunking the frames, but it can actually fill those frames in between now, and you can do a nice slow motion shot of something, and it looks great. It looks like it was shot on like a super high end camera. There is so much stuff out there right now, and it's just kind of an explosion. Honestly, to me right now, the thing is, I this is totally my own guess, but I think we might actually see a little bit of pulling back over the next couple of years, because I think right now AI is just like the magic thing, and everyone's just like throwing, oh, we have a problem, let's throw AI at it. And there are some things where like, no, that is not really the right approach. Some more traditional kind of approach is really the right way to do it. Sure, AI might be cool and it's a buzzword, but let's take a step back and like maybe we'll spend time actually programming something for this, because it's a very same thing every time, and it'd be better for us to do that versus AI. But yeah, if you're wanting to get into it, just get into it. Like don't wait. There's tons of guides out there for everything.
Yeah, and like a totally another viable process for like experimenting is you start with if you have just a normal gaming computer, you can probably run Stable Diffusion just fine, and it's free, it's open source, you can download all that stuff. Automatic 11 is great for playing with it, and there's support for mid-range GPUs, even low-end GPUs for that kind of stuff. But you can always dial things in and experiment on your machine. And you can always hop over to like the cloud using Colab or something like that. If you want to do like some crazy HD render, like you dial it in once on your computer, you spend a couple hours flipping all the switches, you want it local, you get your settings dialed in, it's like cool. Then you can flip over to the cloud and just shoot it off once, cost you like $1. And now you have whatever high-end quality thing that you're trying to do too, which is a great, viable way to kind of combine the different worlds of local and cloud if you need to.
Yeah, we actually sell quite a few machines for that. Not as much for AI yet, but for a lot of like developers, more like HPC kind of realm. So yeah, they can do it all local. They can play around. It doesn't really cost them money to play around then. And then when they get to like the things that do cost big money, if you're running it, 24/7 for a week, they know it's all right. They're not experimenting anymore, right?
Right.
Right.
Yeah.
Niko, before I let you both go, I think it's important to note that you said like the AI part of what you created was just a piece of it. And there was all this other artistry that went into it, including compositing and all that. So, what would you say to the people out there that are a little reticent about using AI in the creative process? What's your message to them?
Yeah. Well, I mean, first, I think the term AI is very much like a movie term, that we all like to say because it sounds cool. The reality, it's a machine learning process. It's a statistical like correlation process, analytical process. Um, and you can this process can be used for many things. It can be used for text and language, as we see with ChatGPT and GPT-3 and 4. It can be used for images, as we see with diffusion models. It can be used to replicate things. It can be used to duplicate things. Kind of. It's not the same as copying something. It's different. Like there's a nuance there, but it can generalize somebody's art style. It can generalize some aesthetic. It can do that stuff. But as an artist, if you try to use it, you quickly realize that you want it to bring your ideas to life. And the only way it can bring your ideas to life, if they're new ideas, is for you to teach it these new ideas. Because it is kind of this like I said, kind of a mental collage of things. It can mix things that already exist. It can kind of replicate generalized versions or mixes of things that already exist. But really, when you're creating something, you're trying to create something new, something that hasn't been said 1,000 times before or shown 1,000 times before. And there's inspirations from that old stuff, and there's that aspect to it. But this is where the magic stops. The magic of AI stops, where it's like, oh, just create anything. It's like, well, no, it's a machine learning statistical model, right? It doesn't create anything. It creates what it knows and can blend those things and work those tools depending on how it's made. And so it's crazy. It's new. It's changing fast. It's powerful, but it's still just a tool. So I really recommend that people out there who are concerned about it, download it and start playing with it. If you're truly concerned about it, it's like, go grab some of this stuff. It's free. Like, there's Stable Diffusion, Automatic 1111. That's a great spot to start. If you want to look at large language models, like, there's ChatGPT and that kind of stuff, you can play with that. But Facebook just released Llama, I think Llama 2, which is an open source language model. So you can get into that as well, and you start experimenting with all that kind of stuff. And if you really think that it's, something to be scared of, or that's something that you're very concerned about, you should get your hands on it. You should try it out. Like, it's not an inaccessible thing. And what I really don't want to have happen is that the narrative around this gets driven so negatively that it becomes a very like regulated and corporate controlled thing. Um, like, there's already, I think Adobe proposed some new legislation or is backing some new legislation, which is like, I'm very much like, oh, do not go there. And I need to look into it more. But it's starting to get into this realm of like, well, you can't create this because somebody's kind of already thinking about it first, and like, that's not the world of art to me. Um, so yeah, it's, if you're worried of it, about it, you're afraid of it. I don't mean that negatively. It's obviously, it's fresh, it's new, it's changing things, and that can be scary. Um, but you should utilize it. You should look at it. You should get your hands on it, um, and see where its limitations are. See what it's good at, and incorporate that into your process so that you can be a more powerful artist or a more powerful creator. Because, like I said, this stuff is not magic. Um, it's used just like anything else. You have to give it creative inspiration. You have to give it direction. It has to be part of your arsenal to tell your story or create your work for it to really have value. And I think you'll see that. I mean, there's already billions of AI images out there, right, that just have flooded the internet over the past year. And we don't necessarily value that any like more right now. Like, even there's always great crazy images that are aesthetically pleasing, like, we still follow artists. We're still looking at the human side of things. That hasn't really changed. And we've already been in this world for a whole year. Yeah, I don't know, it's crazy. It's, who knows where it's going to a certain extent, but that's why I'm working with it and playing with it and experimenting with it, because it's, why not?
Okay, and the sequel to, or the next chapter for, anime rock paper scissors, should be out by the time people are watching or listening to this, and they can see it on
Mhm.
your YouTube channel.
So it's going to be on our website, corridordigital.com.
Okay,
So go there and
fantastic.
check it out. It's 15 minutes long. The first one had 80 shots. This one has almost 400 shots. We have a whole new like process we came up with for animating this stuff. We'll actually have a 3-part tutorial on our website as well, so people can see the whole process. Not just how we train Stable Diffusion to do video for our actors, but also how we do the backgrounds, which I have a feeling that the method that we're using for backgrounds is quickly going to be the method used for backgrounds and pretty much all traditional animation. um, we'll see. I mean, not saying that like we're inventing it. It's a pretty kind of basic thing, but we're seeing the power of it. And also an unsung hero in all of this is, I think, running Resolve and running Fusion on our Puget systems, because all the compositing that has to happen, all the animation that has to happen. Previously, we were doing a lot of that in After Effects, and now it's split a lot more between Fusion and After Effects. And Fusion is very GPU accelerated, and compositing and animating in real time is something I've never really experienced being a big After Effects guy. After Effects is very much like let it render, and then see what happens. And that was a very refreshing and fun experience to just be working in Fusion, and like you're hitting play while you're adjusting your masks and moving your keyframes, and it's never paused. It's all just moving while it's happening. So you're just seeing it in real time, like you're almost playing a video game. And that was really crazy. That was a really cool part of the process. That was like kind of shadowed by everything else. Yeah. All right. I have a lot to talk about, as you can tell. You've been focused for the past 4 months.
That's why you're doing a 3-part tutorial this time instead of just a 1 part.
It's true. Guys, Matt, Niko, thank you so much. I really appreciate you taking the time.
Thank you for watching Post Perspectives Meet the Artist podcast, sponsored by Puget Systems. For more information, please visit pugetsystems.com.